I'm going to let you try this one. What is the mean and the standard deviation? So I want to know what is the new mean and what is the new standard deviation. What is the new mean and what is the new standard deviation? Mitchell's not here, James is here, Myers is not here, Travis is here, Josh is not here, Barrett's here, Monica is here, Rebecca's not here, DeQuasia is here. Just thinking about the little legs and the peanut butter. What is my new mean going to be? 3. My mean doesn't change. The mean is the mean is the mean. So if this was my original mean, my new mean is going to be the same thing. Because it is quote unquote group data, meaning you have all of these samples, you've got to redo your standard deviation. So how am I going to get my quote unquote new standard deviation? Old standard deviation divided by the square root of the size of the sample. So what is my old standard deviation? Square root of 3 divided by the square root of 50. Now that looks gross, but that's all they wanted to know. So if I come down, that is what this is saying. This is saying that this is my mean, and they're saying that this is my new standard deviation, which we also call the standard error of the mean. So the mean is always the mean. The standard deviation is going to be the old standard deviation divided by the square root of the size of the group. And if they wanted me to type in this calculator, be careful though when you're typing this into the calculator, because a lot of you are going to do this. And this is going to be wrong. That square root of 3 is the only thing that is in that upstairs square root. Right now, you have the square root of 50 within that square root of 3 because you didn't end that parentheses. Y'all with me? So this is going to be totally wrong. What you have to do is you have to say, I want to do the square root of 3 and close what's in that square root. Then divide it by the square root of 50 and close what's in that square root. So if I told you to type that in, a lot of people are going to miss that right there, because you're doing the square root of 3 only divided by the square root of 50 only. And if you didn't put that, then that means that you're putting all of this underneath that square root. So you're really doing the square root of the square root, which is going to give you a different answer. What is the probability? So what are we trying to find? The shade, the area, the probability. What is the probability that a simple random sample of 50 10-gram portions results in a mean of at least 3.6 insect fragments? Is it unusual? And what might we conclude? We'll let you try that one. And again, I'll pull this down if you need me to. I don't think you need to see it, but I'll pull it down just in case. And we'll come around and look at this one. Bless you.
Thank you. Nope.
Of at least 3.6. If you have at least $3.60 in your pocket. At least $3.60 in your pocket. At least $3.60 in your pocket. Do you have 360 or less, or do you have 360 or more? If you have at least $3.60 in your pocket. I'm walking around with at least $100 in my pocket. How much money do I have? Not yet. At least 3.6. At least 3.6. What did we say our mean was in the last problem, James? Draw your picture. That's our mean. Yeah, you got it. At least 3.6. So at least 3.6 is 3.6 or lower. So if you have at least $100 in your pocket, $100 or less, or you have $100 or more. Okay, so you're doing $100 or less. You with me? At least $100 in your pocket. So this says at least 3.6. Would be 3.6. You rounded that a little too much. I put in some more. That gave me closer to what I wanted. So just don't cut that one too short, because my math I will yell at you. There you go. Yes, ma'am. All right, in the last problem, putting it all together is the hard part. In the last problem, you told me what the mean and the standard deviation was. You said that the mean is 3. So when I draw my picture, you told me that the mean is the mean is the mean. And you told me that the new standard deviation is the old standard deviation. What was the old standard deviation? Square root of 3 divided by the square root of the size of the group. Yay? That's what y'all just told me in part B. Now, the random sample of 50 we've taken care of there. The mean, we said the mean is the mean is the mean. At least 3.6. This is where a lot of y'all are screwing up. At least 3.6. So most of you knew that 3.6 was like your data point. Was like your sample of means. You knew that. But you shaded the wrong way. If you have at least $360, that means you have $360 or more. Most of y'all did or less. If you have at least $360, you have $360 or more in your pocket. So you should have been shading this way. And because we're trying to find the shade, we're trying to find the probability, we're going to do normal CDF. Where did I begin? 3.6. Where did I end? 99999. What is my mean? 3 of my standard deviation is square root of 3 over square root of 50. Most of y'all were doing, that we're messing up, we're doing from negative 99999 to 3.6. You were doing the shade below instead of the shade above. Now, when I do that in my calculator, second bars, normal CDF, 3.6 is my shade to the left, 99999 is my shade to the right, 3 is my mean, square root of 3, close it, divided by square root of 50, close it. That was the answer I was looking for. So the probability that you're going to have that happen is 0.7%. It is unusual because it is less than 0.05, because 0.7% is less than 5%. Good? All right, that was it for 8.1. Let me save that. So that was it for 8.1. Now we're going to be dealing with 8.2. Now, 8.1, chapter 7 was just the plain data. 8.1 is when we were dealing with means. I did samples of this and calculated an average. And averages of this sample, and averages of this sample, and averages of this sample. So it was like that group data. Okay? Now we're going to talk about 8.2. 8.2, we're going to be dealing with proportions. Proportions are like percentages. So we're going to be dealing with proportions or percentages. So up here we had mean, we had standard deviation, we had sample size. In 8.2, you're going to be having a data point. You're going to be having a sample size, and you're going to be having a proportion or a percentage. We're still going to be doing normal CDF. We're still going to be doing shade begins. Where does the shade end? our mean, which is our middle, is now going to be a proportion or a percentage. And we have a new formula at the end. This is kind of like our new standard deviation. Okay? Now, the P and the 1 minus P. So, for example, if my P was 0.4, my 1 minus P is going to be the complement. So if 40% are pregnant, what is the other percent that's not pregnant? 60. Now, we can write it as 0.40 and 1 minus 0.40 if you want to. I mean, it's the same thing. But 0.4 would be my P, and then 1 minus 0.4 is going to be the complement, which is going to be my 0.60. Y'all with me? So if you want to do 0.4 and 1 minus 0.4, that's fine. But you know that these two are going to add up to 1. And then N is going to be your sample size. And it's going to be the square root of the whole thing. All right, so let me pull up. So we're doing the same kind of thing, but now we're doing a lot of proportions. Proportions are like fractions that turn in. So if I say 20 over 100, 0.2, which is 20%. So these are like a lot of percentages, a lot of proportions. In order to be a sampling distribution, these two things must have to happen. So we're going to have to know these. Let me see if those are on your formula sheet. Let's see if I was nice or not. Okay, those two are not on your formula sheet. But in order to be a sampling distributions, and I don't think you have any of these on your test where you have to do these, I automatically say, I think on your homework you have to know this, but on the test you don't have to know this. It's going to say on your homework, show me that it is approximately normal by doing these. I think on your homework you may have to know these. Yes, you do, because you're going to have to say, is it normal or is it not normal? So you do have to know these on your test. So you do need to memorize these. Memorize. N is your sample size. How many people are you asking? P is your percentage, your proportion. And those two things need to be approximately greater than or equal to 10. And this is your number of people you're asking in your sample, and this is a big N. There's a difference between little n and big N. This is the number of people in your population. So N is for your sample, big N is for your population. And I'm going to do several of these so that you don't get confused. So in order for it to be approximately normal, both of these have to happen. Both of these have to happen for it to be approximately normal. This right here is saying that our mean is our mean. This time the only difference is our new mean is going to be a percent. Our new mean is a percentage. A mean is a mean, but our new mean is going to be a percent, but our percent is going to be a decimal. I said percent is a percent instead of percent is a decimal. Our mean is our mean. Whatever the mean is, it's going to be the mean. But with these, our means are always going to be a percentage, a decimal percentage. And then this one is talking about going from our old standard deviation to our new standard deviation. So you're still doing all the basic steps. It's just new formulas. P parentheses 1 minus P all over N, and you're taking the square root of the whole thing. P 1 minus P over N, and we're taking the square root of the whole thing. That's our new standard deviation. We're in the first thing that we did in chapter 7, our standard deviation was just our standard deviation. If we're fat, we're fat. If we're skinny, we're skinny. In 8.1, our new standard deviation is going to be the old standard deviation divided by the square root of the size of the group. In this one, it's going to be P times 1 minus P over N. Sorry, take the square root. If you have just a data point or an X to turn it into a proportion, you're going to divide it by N. So if I say that 20 people, P-E-O-P-L-E, have a cell phone out of 70, find the sample proportion. What would 20 people out of 70 be as a sample proportion? Not all at once. What does proportion mean? A percentage. So what do we have to do with that fraction? 20 over 70. So in my calculator, probably not pretty, 20 over 70. 0.2857. So this is just saying if I give you two things, you're going to turn it into a fraction and make it a decimal, or whoop whoop and make it a percentage. P hat, this one is called P hat. It's like wearing a little dunce hat. P hat, it's like fat now. P hat is the sample proportion. P is the population proportion. And y'all, we're at the end of the semester, but we're talking about stuff that we did at the beginning of the semester. Sample, population. So P hat is talking about my sample. P is talking about my population. So we have, and it's a statistic about my sample. It's a parameter about my population. So P hat talks about the sample. P talks about the population. Just like before, if I say find the area, find the probability, find the shade, we're going to use normal CDF. Where does the shade begin? Where does the shade end? What is the probability? That's going to be my mean, the same thing as my mean. And then my quote-unquote new standard deviation is going to be P times 1 minus P all over N, take the square root. So we're still doing the same thing, it's just according to what kind of data they give us. The blank blank denoted by P hat. So what did I say P hat stood for?
Sample proportion.
Sample proportion. So the sample proportion is the same thing as P hat. Is given by the formula where P hat equals blank over blank. So if I said 20 people have a cell phone out of 70, what would my formula be? X divided by N. Take your data and divide it by how many people are in your sample. So X is going to be like your data, and N is going to be like the number of people in the sample. 20 people have a cell phone out of 70 people in the group, in the sample. And sometimes they'll give you the percentage, and you don't have to do that. The mean of the sampling distribution of the sample is the same as the mean of the population. The mean is the mean. True or false? True. Y'all, we did this the very first day. I handed y'all those index cards and I said, if 75% of y'all have a cell phone with texting, then I am going to infer that 75% of the population has a cell phone. So if 75% of the sample proportion has a cell phone, then we're going to assume that 75% of all of Lawrence Darlington Tech has a cell phone. So your average should be the same as the school's average. Okay, so this is saying that the sample population's average should be the same as the population proportion's average. The mean is the mean. The mean is the mean. The sample mean, sample proportion, is the same as the population proportion. Those are going to be the same. Describe the circumstances under which the shape of the sampling distribution of p hat is approximately normal. So in the 8.1, it was normal when you had asked about how many people? 30. Okay, so as long as we ask about 30 people in our sampling, then it was normal. Well, in this one, two things have to happen in order for it to be normal. Oops, let me grab the whole thing. In order for your shape to be normal, both of these must be true. So in 8.1, in order for it to be normal, you had to ask at least 30 people. In 8.2, in order for it to be normal, this and this have to be true in order for it to be normal. And we're going to do some with it. We just have to memorize this, and we'll talk about it in just a second. Okay, describe the sampling distribution. Okay, so that means you're going to tell me, is it approximately normal or not? That's the first thing we're going to do. Is it normal or not? Which means we're going to use copy, paste, erase. So the first thing I'm going to ask myself, is it normal or not? Is it normal or not? So if I ask a 300-person sample a question, and 70% of that population tells me something, and the size of the population is 25,000, I need to be able to look at these two things. So what was my little n? My little n was 300. 0.05. What do you think my big N is? My little n is the size of the sample. My big N is the size of the population. It's capital because it means something big. So what is the size of my population? 25,000. So I'm going to go to my calculator and I'm going to do 0.05 times 25,000. And I get 1250. So the first part is 300 less than or equal to 1250? Yes. So we're halfway there. Now we've got to answer this second part. What is my N? 300. What is my P? 0.7. Now I'm going to show you two ways you can do it. It does not matter to me. You can do 300 times 0.7 times 1 minus 0.7. Or you can do 300 times